Poland has quietly engineered one of the most consequential shifts in NATO's short-range air defense landscape, and it did so not with a flashy unveiling but with sustained industrial discipline. Polska Grupa Zbrojeniowa, PGZ, is producing roughly 1,300 Piorun man-portable air defense missiles annually and, by its own projections, plans to double that output within 3 to 4 years. In practical terms, this means a single European supplier is now outpacing the combined output of the US Stinger and France's Mistral lines, an inversion few would have predicted a decade ago. For allies struggling to replenish stocks depleted by donations to Ukraine and elevated readiness levels, Poland's surge is less a headline and more a lifeline. The scale is a product of intent as much as capacity. Warsaw's 2023 to 2035 National Armament Plan treats munitions and air defense as strategic infrastructure rather than a contingency purchase. Within that framework, Mesko SA leads final assembly and energetics, Telesystem Mesko delivers the guidance suite anchored by a cooled infrared seeker, and the Military Institute of Armament Technology provides test and certification rigor. Investments at Mesko's Skarżysko-Kamienna complex, particularly in rocket motors, electronics, and quality systems, have shortened cycle times and stabilized yields. The result is a rare combination in defense production, predictable throughput at scale, in a category where Western lines have often been episodic, boutique, or hampered by obsolescent components. Piorun's battlefield reputation has been earned rather than advertised. In Ukraine, the system has been credited by operators with kills against attack helicopters, low-flying fixed-wing aircraft, Shahid-class loitering munitions, and cruise missiles executing terrain masking profiles. Two design choices stand out. First, the cooled IR seeker offers higher sensitivity and better resistance to flares and clutter than uncooled heritage seekers. Pre-launch programming allows the operator to tune seeker behavior to background conditions and target class. Second, a dual-mode fuse, impact plus proximity, increases lethality against small drones and cruise missiles that might otherwise slip past a purely contact fuse design. These are not incremental tweaks, they are features aligned to the threat set modern ground units face daily. The missile's engagement envelope, roughly 400 meters to 6.5 kilometers in range and up to about 4,000 meters in altitude, positions Piorun in a sweet spot between ultra-short-range, point defense tools and heavier short-range systems. The complete set, combining a reusable gripstock with a sealed launch tube, weighs around 19.5 kilograms, a figure that matters to infantry who carry it over distance and time. Day and night sights, user authorization, and IFF connectivity reduce the risk of misidentification while enabling integration into wider air defense networks. In Polish service, that networked approach is not theoretical. Piorun teams are queued and supported by Poprad self-propelled launchers and PSRA Pilica and Pilica Plus batteries, which add electro-optical tracking and networked fire control. The effect is to turn distributed two-person MANPADS crews into nodes in a cooperative SHORAD mesh. International comparisons reveal why demand is growing. The US FIM-92 Stinger, combat-proven and widely fielded, has faced redesign and requalification of aging components, a reality that slows surge capacity. France's Mistral 3, with its imaging IR seeker, heavier warhead, and longer maximum range, offers formidable performance at the cost of bulk and price, less ideal for mass distribution to line units. Britain's Starstreak, a laser beam rider, is exceptionally fast and effective against pop-up targets but demands uninterrupted line of sight and stable laser designation, placing higher training and environmental demands on crews. Piorun's calling card is balance, a modern cooled seeker hardened against countermeasures, a proximity fuse folded into an infantry portable package, and production lines that can deliver in quantity now. Availability, predictably, breeds customers. Norway has fielded Piorun in Finnmark, adding deterrent value along NATO's northern flank. Estonia, Latvia, and Moldova have joined the user community, while Ukraine employs the system in combat conditions that stress every subsystem. Sweden concluded a significant order in 2025, with deliveries scheduled mid-decade, and Belgium approved funding for launchers and several hundred missiles. The United States has signaled its intent to buy a substantial batch as an interim measure while a next-generation interceptor matures. Discussions of joint procurement frameworks, among them Lithuania and Norway, reflect a recognition that Poland's volume can compress delivery timelines and stabilize sustainment. The industrial effects radiate beyond one missile. By building a dense ecosystem spanning energetics, optics, precision electronics, and quality assurance, Poland is anchoring a regional supply chain for air defense components. Parallel investments in small-caliber ammunition and 155mm artillery shells are expanding the skilled workforce and tooling base in central and southeastern Poland. That matters for NATO because resilience is not only about designs and budgets, it is about repeatable manufacturing with suppliers who can deliver the 50,000th unit with the same quality as the 500th. In this respect, Poland has shifted from net importer to net exporter in a niche that has been chronically undersupplied. There are, of course, risks and constraints. Sustaining a doubling of output will test supplier margins, energy costs, and labor pipelines at the very moment when other NATO states are also ramping munitions lines. Electronic component availability remains a perennial vulnerability, particularly for cooled seekers and guidance modules that rely on specialized manufacturing. Training pipelines must keep pace. A network-centric VSHORAD concept lives or dies by the proficiency of crews and the reliability of queuing and communication links. And integration with National Air Defense Command architectures, data formats, AFF protocols, deconfliction with higher-tier interceptors, requires as much bureaucratic stamina as it does engineering finesse. Looking ahead, the proposed Piorun NG points to the direction of travel: extended reach beyond 8 kilometers, a fully digital seeker with improved discrimination and countermeasure logic, and deeper integration with Pilica Plus and the Narew short-range air defense batteries. If Poland can retain the disposable tube/reusable gripstock logistics model while adding range and seeker sophistication, it will keep the system relevant against colder, faster, more maneuverable threats. Such an evolution would also reinforce the core advantage Poland has created, volume at credible performance, by ensuring the missile remains tactically competitive across the 2030s. For NATO ground forces, the practical impact is immediate. Piorun gives platoons, air defense troops, and point defense teams a network-ready answer to the full spectrum of low-altitude threats: Group 1 to 3 UAVs, attack helicopters lurking in nap-of-the-earth corridors, and cruise missiles exploiting terrain. For NATO planners, Poland's leadership in this category signals something larger than a procurement win. It suggests a durable rebalancing of Europe's defense industrial map, with a Polish corridor of production capacity extending across the Baltic and Central European states. The alliance has long preached decentralization of critical munitions. Warsaw has built it. In a defense economy defined by attrition, credible performance, and the ability to deliver at scale, that combination is not just advantageous, it is transformative.